Okay, I got most of these new caps installed, at least all the ones that are mounted on this board. This one over here too. And right now what I'm doing is wiring in the hard wires for our new pots. We're gonna replace these three. But you see what I mean? Here's like our standard. Here's a standard potentiometer. I think this one's what I don't know. This one's Japanese or Chinese or something. But this is kind of a standard mini-sized pot, and this is the original Sovtek Russian pot, and you can see the difference in the size of those shafts right there. And you know, when we're on the subject of shaft size, in this instance, size kind of does matter because these are just really flimsy. Well, I say flimsy. They're not. It's not like they're moving around. It's just that they're not very well constructed and they don't hold up that well. That's why you see so many of these with replaced knobs on the front. Because the thing is, when you go to replace a knob on these, the original ones are made to fit this size shaft. So they have a real tiny hole. And this is the standard size that goes on here. So, yep. Some people actually come in here and drill these out if they're going to try to reuse them. I think I've heard of people doing that. I guess you could. You've got a little bit of room there. It looks like between here and where you kind of have to stop. So you might be able to pull that off, but you might be able to pull off that shaft, make it work, and put it in the hole. Another thing the previous tech did as well, it looks like they sprayed WD-40 or something inside of these pots, or some oil, maybe, because look, you see when I'm turning the pot right there, see all the, you can see the oil slick kind of changing the transparency of this wafer on the back. There's like oil down inside of it, and that's all three pots are like this. Alright, I think I've got all my pots now sorted out, and some of these have pretty long shafts though. You can see how much shorter the shaft is on this one than it is on this one. We're going to cut this one down and a couple of the others as well. I found a 5K also, and this one is really big, and the shaft is really long, so we're gonna have to cut it down some too. So let's get to work on that. Yeah, it's a little bit more consistent. That's the end of that cutting wheel. Damn it. Shit. Alright, maybe third time's the charm. There we go. Damn. Okay, again, neither one of these schematics are really very accurate, and I'm replacing all three of these resistors right here. This one's kind of burnt, you can't really read it, but I measured across it, and it's about 500 ohms, and also traced it out, and this wire right here goes to the tip of this big capacitor right here, which is this right here. So this is our 510 ohm. It's supposed to be R31. It's labeled on here, but it's actually R36 in our board. So you got to be careful with these. You know, don't just assume your schematic's going to match what you're seeing inside one of these amps, because it looks like they relabeled their boards as they went along. I haven't really found any date codes on this thing that I recognize. You know, it's pretty much all in Russian. So it might as well be Greek to me. But at any rate, we're going to replace this resistor and the other two beside it. And I'm assuming the other resistors are these right here, this 5.1K and this 51K. These three here are pretty crispy. So we're going to replace those, but the problem is I don't really know what watt rating. They didn't give me a watt rating on any of these schematics either, and this thing is so crispy you can't really glean anything off of it. So we're going to use Ohm's law to determine what the watt rating should be on this, and I'll show you how to do that. Okay, one of these schematics does show the wattage ratings for the resistors on the power rail, and it lists them at 3 watts for the 500, 1 watt, and 1 watt for the 5.1 and 51K. We are going to up these values. I'm going to up this one to a 5 watt. I'm going to up both of these to 2 watts each, and that's going to hopefully keep them from burning up and crisping up like they were. Alright, so here are these 3 resistors off the board, and you can see how black and crispy and nasty they look. But I was actually mistaken. These 2 gray ones right here, these are not dropping resistors from the power rail. If I look at I was kind of confused by it. I looked at the value there, 470 RJ, and the other one has the same value, which, so if they were the power rail resistors, they shouldn't have the same value. What those are actually the 470 ohm screen resistors. If we follow the wire that comes off of here, one of them's going to this screen and one of them is going to this screen. So those are the screen resistors. They need to be replaced anyway, so it's a good thing I pulled them off the board. This resistor right here, R29, it doesn't look crispy at all, but we may replace it anyway. I don't know, we'll see on this one. This is a dropping resistor in the power rail. It actually looks pretty good. But if I trace it over, the next one in the power rail is this one, and that one right there does look fairly crispy. So we may replace this one as well. I'll see what I have. I don't know if I have the correct value in a 2-watter. Alright, there's our new 500 ohm 5 watt resistor installed. Now these screen resistors, we're going to up the value of those up to 1K. What that's going to do is it's going to lower the screen voltages a little bit and help keep the tubes hopefully from overheating. Alright, there are 3 of our new resistors, and I've been careful not to put those all the way down against the board, so they're elevated up off the board a little bit. That's going to give them some clearance and allow air to flow around them, help dissipate some heat. Now this second resistor on the power rail, it is measuring dead freaking on. I mean, that's about as close as you can ask a resistor to be that's on a power rail like this and of this age. So that thing is holding strong, and I'm going to leave it in place. Now this other one over here I am going to go ahead and replace, but unfortunately I don't have an ideal resistor on hand for that. But we're going to actually improve it anyway, and we'll put a resistor in there, but all I have on hand is a carbon. It would be nicer to have like a, you know, a metal film resistor for that spot on the power rail, but you know, I've got to work with what I've got to work with at the moment, but it'll at least be better than the one that's in there, so we'll go ahead and replace it too. Okay, one note on this: if you're changing pots, all of the holes for these pots on the front of this chassis are in some kind of metric measurement. I'm not sure what the measurement is, but you'll want to slightly drill these out if you're using some of these larger shafted pots like this. Otherwise they won't really fit in very easily. So what you got to do is go down to, let's see, what is the size? I think it's 3/8. Yeah, you got to go down to 3/8, which I just did, and it was just barely taking off any material at all, but it at least makes it where you can use standard American sized stuff. Alright, so the owner of this amp might be in luck. I've actually serviced one of these MIG-50s before, and had a couple of extra knobs that I salvaged from one of those. So it looks like I've got a full set of Sovtek knobs here that I can put on there for him, but we just need to drill these out. Alright, the first thing I want to do here is back the set screw all the way out, because otherwise we're going to run into problems with that set screw. And the size that is, that's a, let's see, that's a 1/4 inch. Okay, I have all the knobs on this thing and they look pretty good.